So I thought I'd do a video explaining how I put the compressor together and configure all the components, because when I was looking around YouTube, I didn't find something that kind of, summarized everything in a great way. But I was able to get access to a lot of these parts for basically free, so it kind of made sense for me to do this. And now I got a really good compressor. So I already had the tank with a smaller head on it, and it wasn't really cutting it. So I had access to this other bigger pump head, and then I had an old pump sitting around with this 7.5 horse motor on it, and it decided to make something better out of them. So basically what you need to do is the tank more or less is just kind of a buffer. So in other words, like the bigger the tank, the longer the storage of air will last when you're using it, so your pump doesn't have to run as frequently. So generally, bigger tank is always better, but it doesn't necessarily, any given size motor, CFM doesn't demand a certain size tank. But what does matter is basically the motor to the pump head, and then the RPMs and such. So what I ended up doing was I found the specifications for that compressor head, and basically the manufacturer told me that with 7.5 horsepower, it needs to be driven at 1500 RPM. So then I was able to do the calculation. Basically, it's just like a gear ratio between the diameter of this pulley and this pulley. So you can calculate your ratio to find, because you know the RPM of the motor, because it'll tell you that on the data plate, and then you can buy the right pulley. The other kind of learning process was with this side of the plumbing. So when you need, you have to have a check valve, which I didn't think about beforehand, because you can't have the pressure from the tank backfeeding to the pump head when it's not running. And it has to be a specific type of check valve, because I actually used this valve. It's just a generic, it's kind of got like a flat tappet, but it's when I first ran it, I thought the pump head was knocking like crazy, but it's just this tappet was just flapping like crazy, and it just nuked itself. Like the parts are just loosey-goosey in there. So I got myself a correct check valve there, so now it works all tickety-boo. And the other thing that I wasn't sure about, that I didn't see people explain, was this little line here that goes from the charge pipe system over to your switch. And that's actually called an unloader line. And what that does is when your pump stops running, the switch will actually vent all the pressure that's left in that line. And what that does is once your motor kicks in again, it doesn't have to fight any pressure in the charge pipe. So it's like just kind of giving it an easy start. So then the other thing is you'll have to size a switch based on your power needs, right? Because the motors may be 110 or 220 and whatever amperage. And I know this thing's kind of janky looking right now. I'll put a cage over the pulleys and such, but I just kind of mocked it up to get everything working. And then, so once you have your power needs, you need to figure out, I had to change a breaker because my breaker wasn't big enough. Make sure I had to parallel some wires here because I didn't have heavy enough wire. I'll probably change that down the road, because you need based on your amperage demands, you need the correct breaker and you need the right gauge wire. That's really important, because if you run too narrow or too small a gauge of wire with the amperage, it'll start cooking the wire, right? Because it'll be too much, and then you could get a fire or a short or something. Yeah, so that's kind of the gist of it. It's yeah, in my case, it made sense because I had everything for basically free, and now I have a really strong compressor. So hopefully that helps somebody.